Let's go ahead and create our own implementation of a controller factory. The focus of this demo is to understand the fundamentals of how this component works and when it executes in the lifecycle. Let's also make this demonstration a bit more interesting by building our own implementation of iController. Let's begin by right-clicking on our controllers folder and let's choose to add a new controller. I'll just pick the empty MVC5 controller, choose Add, and give it a name of Contact Controller. Maybe this class is in charge of providing contact information or other related resources on our site. After that's created, the first thing we want to do is change the controller so that it directly implements iController rather than inheriting from the MVC Framework's controller base class. So I can actually just add an I in front of this class, and that'll switch it to the iController interface. We can also hit Control P to auto-implement that interface. And you'll see that our familiar execute method is added to the bottom of our class. We can just delete the index method at the top, since our custom controller doesn't really have any concept of action results. Inside our execute method, let's add some simple code to send a result to the browser. We can get the current response for the HTTP context and then write out a line of text, which is what will be returned to the browser. Remember, the execute method of a controller could do almost anything. It takes a lot of work to get this method to do something meaningful, which is why you almost always just inherit from the controller base class. For our purposes, we just want something simple that will prove the result was generated by this custom controller. Now, one other thing I want to do is give this class a constructor that accepts a parameter. By default, the MVC5 framework cannot create controllers that include parameters. This shortcoming is the most common reason why you would modify the default controller factory's behavior in a real project. So let's imitate that right now. Let's assume we want logging functionality in our application again. So I'll just add a constructor that takes a parameter of type iLoggingService. And after that's in place, we can use Control P again to actually auto-generate that interface for us. After that's in place, let's just peek inside the definition of this logging service and switch it to an interface, since that was generated as a class by default. And then we can go ahead and save and close that. Now let's go ahead and run our application and just see what happens. After our page loads, if we navigate to the URL /contact up in our browser address bar here, you'll see that we get this yellow screen of death. The error message tells us that there's no parameterless constructor defined for this object. Now, another way of thinking about this error is that the controller factory was not able to create a controller that accepts parameters. So let's fix that right now. Back inside our solution, I'll right-click on our project and choose to add a new class. Let's call it Parameter Controller Factory and just hit OK. After that pops in, let's make sure that it implements the iController Factory interface. Again, we can use Control P to quickly bring in a using statement, and then again to actually implement that interface. So here we have those three methods that we discussed in our slides. Again, we're most interested in this create controller method at the top. Now, the default controller factory uses some pretty sophisticated logic to find controllers by name. We're just going to add a simple implementation to work for this isolated scenario. So notice that this create controller method is actually passed in a controller name string parameter. We can use this parameter to decide when to return an instance of our contact controller. So let's just say if the controller name is contact, then we can return a new instance of the contact controller. Now remember, this controller also wants an object that implements iLogger passed into it. So let's just quickly add a class at the bottom here and make sure that it implements this interface. I'll just call it public class logger and just add the interface at the end. And this class doesn't really need to do anything for now. We just want to be able to pass in an instance of it to our contact controller. So after that's in place, we can revisit our constructor and just pass in that logger class. We also need to make sure that all conditions here return a controller instance. Let's just say if we're not requesting the contact controller to always return the home controller, since that's the only other controller in our project right now. This controller requires no parameters, so we can just go ahead and return a new instance of it. Now, the next method on this interface deals with our controller session behavior. This isn't really important to our discussion, so I'm just going to have it return the session state behavior.default. For the release controller method, let's just clear it out and we can leave it empty for right now. Lastly, we need to register this class as the factory that our application should use. Let's jump over to our global.asax file for a moment. We just need to add one line of code inside of the application start event. So let's just say controller builder.current.setControllerFactory, and then we can pass in a new parameter controller factory instance. Now there's actually one last task that we want to do inside of this global.asax file. We want to add a few event handlers like we did in an earlier lesson. The reason we're doing this again is because we want to prove out our discussion from the slides regarding the order in which these components execute. Remember, all of the code we just wrote is triggered by the MVC handler's process request method. Therefore, our controller factory's create controller method and the controller's execute method should both be called between the pre and post request handler execute methods. So I'll just paste those in here to give us a solid context for when this is all happening. We're doing this so that we don't lose our main focus here, which is really understanding when and how all of these steps are executing. Now let's go ahead and run our application, and after that starts, we can set some breakpoints to really illustrate the order of execution. Our application should load like we would expect, so let's jump back over to our project and add in some of those breakpoints. First, let's set breakpoints in the pre and post request handler execute events. Then we can switch back over to our controller factory, and let's add one inside that create controller method. Lastly, we want to add one inside of the execute method of our contact controller. Now with all that in place, let's request that contact URL that gave us the error earlier. This should now be handled by our custom controller and the controller factory. So immediately, you'll see that we first hit the pre-request handler execute method, just like we'd expect. If I hit continue, we jump straight over into our create controller method inside of our factory. This means that the MVC handler has called its process request method, and since we set our controller factory as the default, now that's firing. We need a controller to service the request. If I hit continue again, we jump over to our custom contact controller. Let's continue forward again, and we'll actually jump all the way over to our post request handler execute method. If we continue one last time, we can then move back to our browser. You'll see our familiar message, meaning an appropriate controller was created and executed to service this request. So the MVC handler in our controller factory's work is done. And with all of that working properly, our work here is done too. In the next lesson, we'll begin discussing a more realistic way of handling controllers with parameters by looking more closely at the dependency resolver.